Okay, 90 degrees in radians would be 90 times pi over 180. So that becomes pi over 2. So two coterminal angles. So 90 degrees plus 360 plus one full circle. So 450 is one. And then just repeat the process. So 810 degrees is another one. And 90 degrees is a quadrantal angle. Okay, 7 pi over 4, so to convert that to degrees, I would multiply by 180 degrees over pi. So then the 180 and the 4 can be reduced. So then 7 times 45, 5 gives Okay, so two coterminal angles. So if I add 2 pi, that's the same thing as 8 pi over 4. So 15 pi over 4. Okay, so I can subtract instead. So subtracting 8 pi gives me negative pi over 4. Okay, so 7 pi over 4, 315 degrees is almost all the way around. Okay, 300 degrees. Okay, so 300 and 180 are both divisible by 60. So this becomes 5 pi over 3. Coterminal angles plus 360 would be 760 minus 360 would be negative 60. Okay, and then drawing 300 degrees, it's a little bit past 270, but not all the way to 360. All right, 11 pi over 6. Okay, so 80 and 6 are both divisible by 6, so this becomes 30. So then 11 times 30 would be 330. And then coterminal angles plus 360 and minus 360. Okay, so the drawing almost all the way back around. Okay, negative 2 pi over 3. So negative 120 degrees. So if we add 2 pi, which is the same thing as 6 pi over 3, we could get 4 pi over 3. Or if we subtracted 6 pi over 3 instead, we get negative 8 pi over 3. Okay, so this time we're going counterclockwise into quadrant 3. Okay, so sine opposite over hypotenuse. So in quadrants 1 and 2, the opposite side and the hypotenuse are both positive. But then in quadrants 3 and 4, the opposite side is negative, which makes the sine value negative as well. All right, cosine. So cosine is adjacent over hypotenuse. Okay, so in quadrant 1, adjacent and hypotenuse are both positive, and also in quadrant 4, the adjacent and hypotenuse are both positive. But then in quadrants 2 and 3, the adjacent side is negative, which makes this cosine negative. Okay, Okay, tangent, opposite over adjacent. So in quadrant 1, opposite and adjacent are both positive, and in quadrant 3, opposite and adjacent are both negative, and negative divided by negative is positive. Okay, so then on the other hand, in quadrant 2, opposite is positive but adjacent is negative. Positive divided by negative is negative. And in quadrant 4, we've got positive and negative again. Okay, filling out the unit circle. Oops. So I'll start with the quadrantal angles. Okay, so this could be 0 degrees, or it could be all the way around. Okay, so then I know that halfway through the circle is 180 degrees, and then half of 2 pi full circle would be pi. Okay, then this is halfway of halfway, so 1/4 of the way through the circle. Half of 180 is 90 degrees. Half of pi is pi over 2. Okay, and then over here, this is 3 times this one, so 90 times 3 is 270, and then 3 times pi over 2 is 3 pi over 2. Okay, so now the individual degrees. And then here to here is 30, so here to here is also 30 past it. 45 to 90 is plus 45, so 90 plus 45 is 135. 30 to 90 is plus 60, so 90 plus 60 is 150. Okay, and so the radians. Okay, so once I have the first quadrant, the rest of the radians can be found through multiplication. For example, 120 degrees is double 60, so what's double pi over 3? That'd be 2 pi over 3. Okay, so 135 is 3 times 45 degrees, so pi over 4 times 3. 150 degrees is 5 times pi over 6, or sorry, it's 5 times 30 degrees, so I do 5 times pi over 6 as well. Okay, so let's fill out the rest of it. Oops. Okay, so 210 is 7 times 30, so 7 times pi over 6 is 7 pi over 6. 225 is 5 times 45, so 5 times pi over 4 is 5 pi over 4. 240, I could use a lot of angles. 240 is double 120, so what's double 2 pi over 3? That'd be 4 pi over 3. 300 is 5 times 60, so 5 pi over 3. Okay, 315 is 7 times 45 degrees, so 7 times pi over 4 is 7 pi over 4. And 330 is 11 times 30, so 11 times pi over 6. Okay, so for my coordinates, again, I know that the non-quadrantal angles only use 1/2 radical 2 over 2 and radical 3 over 2. So in this quadrant, this is the lowest point, so the smallest y value is 1/2. The next largest y value is radical 2 over 2, and the greatest y value is radical 3 over 2. And then for the x coordinates, I know that after 0, the next smallest x coordinate would go right here, which is 1/2. The next greatest x coordinate goes right here, and the greatest x coordinate goes right here. Okay, so the rest I can do by reflection. So this point gets reflected over the y-axis, meaning the x-coordinate becomes negative, but then the y-coordinate is exactly the same height. Okay, same thing over here. All of these I just take the quadrant 1 point but change the x value to negative. Okay, so now comparing this quadrant 2 to quadrant 3. So the x-coordinate's still negative, I still go to the left, but now the y-coordinate gets reflected and becomes negative as well. Okay, so lastly for quadrant 4, I'll go back to quadrant 1 and just reflect it over the x-axis. So the x-coordinate is the same, but the y-coordinate becomes negative. Okay, so now that the unit circle's done, the trig value should be easy. Sine of 30 degrees. So I just want to remind myself that for the points x comma y, x represents the cosine, y represents the sine, and y divided by x is the tangent. Okay, so sine of 30 degrees is the y-coordinate. Cosine of pi over 4 is the x-coordinate. Tangent of 270 degrees is y over x, so negative 1 over 0, which is undefined. Cosine of pi, so the x-coordinate is negative 1. Sine of negative pi over 6, so negative pi over 6, I go clockwise. Sine is the y value. Tangent of 135, so y over x. Tangent of 4 pi over 3, so again y over x. Cosine of 0, I want the x-coordinate. Sine of 180 degrees, I want the y-coordinate. Sine of 2 pi over 3, I want the y-coordinate. Cosine of negative 45 degrees, I want the x-coordinate. Tangent of negative pi, so again y over x. Sine of 315 degrees, I want the y-coordinate. Tangent of 11 pi over 6. Cosine of 5 pi over 6, I want the x-coordinate. And sine of negative 3 pi over 4, I want the y-coordinate. Okay, so I know for all trig functions the domain's all real numbers, so I'll just do those right now. Okay, so let's see, this one, the period is unchanged, there's no b value, and there's no phase shift either because, well, let me just copy down the general form. Okay, so h, there's nothing getting subtracted to this x, so phase shift is 0. Midline shift is 3. Amplitude, the coefficient, so it's negative 1's the coefficient, but the amplitude is always positive. Okay, so the range, well, I already know that, so for my graph, the midline will be 3, and then the amplitude of 1 says I go 1 unit below 3, which is 2, and I'll also go 1 unit above 3 for the maximum, which will be at 4. Okay, so since there's no phase shift, I know I start at 0 on the midline, because that's what sine does. Sine looks like this. Starts on the midline. And then the period means I stop after 2 pi, or I return to the midline. And I know the way sine works, I also hit the midline halfway through the period. Okay, so then for sine, I hit the maximum halfway between these two midline points, and according to the amplitude, oh, sorry, this one's negative sine though. So this is regular sine, but then negative sine will get reflected. Okay, so that means the minimum occurs first, then the maximum. Okay, so minimum would be right here. Again, I know to go down 1 unit due to the amplitude. And then the maximum occurs between the middle and end of the period. So right here at 3 pi over 2. And then because the amplitude is 1, I know the maximum is 1 unit above. Okay, so for this one we need to factor. Okay, so there's no k value, so midline shift is 0. That means the range is 3 units above 0 and 3 units below 0. Okay, the period, well, b is 2, so the period is 2 pi over 2, which is simply pi. Oh, wrote that on the wrong one. So the amplitude, the a value is 3. Phase shift, remember it's minus h, so to get a plus I must have subtracted a negative. Okay, so cosine normally looks like this. So it starts at its maximum at 0, but this time there's a phase shift of pi over 2 units to the left. Okay, so instead of starting at 0, I'm going to start at pi over 2. And due to the amplitude, I know the maximum is at 3. Okay, so the period of pi means, oh sorry, this is negative pi over 2. Okay, so after pi units after I begin, I've completed 1 cycle. So negative pi over 2 plus pi means I end at pi over 2. Okay, so I know that for cosine, at the end of the period, I'm back to the maximum. Okay, so I also know for cosine, the minimum occurs halfway between. So halfway between negative pi over 2 and pi over 2 is 0. So the minimum would be right here. And then the midline zeros, or the midline points, occur 1/4 and 3/4 of the way through. So that'd be negative pi over 4 and positive pi over 4. Okay, so amplitude is 0.5. Phase shift, there's nothing getting subtracted from x, so h is 0. Midline shift is -1. Okay, the period, again, this was for last problem. So the period is now 2 pi over b becomes 2 pi over 3. Okay, so the range, well, I know the new midline is -1, and the amplitude tells me I go half a unit below it and half a unit above it. Okay, so again, I know that sine looks like this. Okay, so the period begins at the midline. So in this case, there's no phase shift, so I do put my first midline point at 0. And the period tells me that the period ends at 2 pi over 3, which is when I return to the midline point, or midline. And then I also know that I have a 0 halfway between. Okay, so the amplitude tells me that the maximum is just half a unit above -1, so -1/2. And that occurs halfway between the midline points. And then the minimum occurs halfway between the other two midline points. So let's see, 2 pi over 6, 4 pi over 6, 3 pi over 6. Okay, so here midline shift is 1, phase shift is pi over 4, amplitude is 2, period, there is no coefficient, so it's 1, so 2 pi over 1 is still 2 pi. Okay, so the range, I know the midline is at positive 1, so 2 units below 1 is negative 1, and then 2 units above 1 is at positive 3. Okay, so normally cosine looks like this, starting at its maximum, but because there's a phase shift of pi over 4 to the right, I know the maximum will start not at 0, but at pi over 4. Okay, and then the maximum, again, is 2 units above the midline. Okay, so then the period is 2 pi, so starting at pi over 4, after 2 pi additional units, I'll end my period. So pi over 4 plus 2 pi would be 9 pi over 4, and that's when I'm back at the maximum. And then halfway between the maximums is the minimum. So that occurs 2 units below the midline at negative 1. And the midline points occur halfway between the minimums and maximums. So at 3 pi over 4 and 7 pi over 4. All right, so midline shift -2, phase shift is positive pi, amplitude invisible 1, period, there's no coefficient, so 2 pi over 1 is 2 pi. Range, well, if the midline's -2, the minimums will be 1 unit below it and 1 unit above it. Okay, so normally sine begins at 0, but because the midline shift is pi, the midline point is at pi instead. And then the period's 2 pi, so after 2 pi additional units, so pi plus 2 pi is 3 pi, I'm back at the midline. And then halfway between the endpoints is another midline point. Okay, so there's a maximum that occurs halfway between the first 2 midline points. The amplitude tells me the maximum is 1 unit up. And then there's a minimum between the other 2 midline points. The amplitude tells me it's 1 unit down. So sorry, this is 3 pi over 2, and this one's 5 pi over 2. Okay, so for this first graph, I see the midline is at 1, so the k value will be 1. Next, I want to find the period. So 1 cycle of the sine takes pi units. Okay, so I know the function, or the equation, is 2 pi over b. So in this case, b must be 2. Okay, so is there a phase shift? Not for sine, because sine, the parent sine function does have its first midline point at 0, which is where this one does. Okay, so sine of 2x. And then the amplitude, the maximum is 3 units above the midline. All right, so what if I want to rewrite the same function with cosine? Okay, so for cosine, I might look at this period right here. So from maximum to maximum. Okay, so the maximum occurs at an x value of halfway between 0 and pi over 2, so that must be pi over 4. Okay, so the amplitude will be the same, the midline shift is the same, the period will be the same. Okay, but there will be a phase shift. Okay, so this maximum is pi over 4 units to the right of 0. And for cosine, that's where the maximum normally occurs, at 0. So in order to, that means that from the original point, I shifted the maximum pi over 4 units to the right. So h is pi over 4. Okay, the other option was I could have sort of done it the longer way. I could have shifted this maximum all the way back to 0. So this point is at negative 3 pi over 4. So I could have shifted this graph 3 pi over, that means that from the original maximum, I went negative 3 pi over 4 units. So that means that minus negative 3 pi over 4 is plus positive 3 pi over 4. All right, this next one has a midline at negative 2. The amplitude is 2. All right, so is there, well, what's the period? So I can't really see a full period of the sine function, but I know the period is the distance from minimum to minimum. So from negative 3 pi over 2 to 5 pi over 2 is 8 pi over 2 units, which reduces to 4 pi. Okay, so now what is b? So again, 2 pi over b equals 4 pi. So b must be half. Okay, now what about the phase shift? So I know that sine is supposed to have its midline point at 0. So this graph has been translated pi over 2 units to the left. So h is negative pi over 2. So x minus negative pi over 2 becomes x plus pi over 2. Okay, and then what if I wanted to use cosine instead? So like this period, which gets cut off. Okay, well again, the amplitude is still 2, the midline shift is still negative 2, the period is still 4 pi, meaning b is still 1/2. All right, so what's the shift this time? I know that the cosine normally has its maximum at 0. This maximum has been shifted pi over 2 units to the right. So h is positive pi over 2. Okay, and then lastly, this midline is at y equals 1, positive 1. The amplitude, the maximums are 3 units above the midline. Okay, so what about the period? Okay, so let's use this period. Okay, so this goes from negative pi over 4 to positive pi over 4. So the period is pi over 2. Okay, and then the formula for period is 2 pi over b equals pi over 2. Okay, so solving for b must equal 4. All right, and what about the midline, or sorry, the phase shift? So normally sine has its first point at 0, its midline point. This midline point is at negative pi over 4. So we shifted pi over 4 units to the left, which means that x minus negative pi over 4 becomes x plus pi over 4. Okay, so now the thing is, what if we chose a different period? For example, what if we chose this one? Okay, well this time the midline point got shifted pi over 4 units to the right. So to shift to the right, that means that h is positive. So it turns out that these two graphs are exactly the same. Whether you shift the original function pi over 2 units to the left, or pi over 4 units to the left, or pi over 4 units to the right, it'll match up with this graph. Okay, and then what about cosine? So I'll use this period right here. Okay, so it looks like this maximum occurs halfway between negative pi over 4 and 0. So that'd be negative pi over 8. Okay, so the amplitude is the same, the midline shift is the same, the period is the same. But again, cosine normally has its maximum at 0. This one has its maximum at negative pi over 8. So I shifted the graph pi over 8 units to the left, meaning h is negative. So x minus negative pi over 8 becomes x plus pi over 8.